Howdy and welcome back. So the motivation took a little longer than expected. So I'm going to go ahead and finish iterators in this lesson video here, and then I will move on to the brief overview of the STL, and we'll get into the actual implementation of an iterator in a later lesson. So let's go ahead and talk about iterators. So an iterator is going to be an abstraction of a pointer to some element within a sequence. And remember, we said that containers could be viewed as sequences if we know where they start and if we know kind of their end, which was defined conventionally as one past the last element contained within them. However, an iterator is not a pointer. It will, though, implement pointer operations that you're already familiar with. So we'll see that you'll be able to invoke the dereference operator on an iterator. An iterator is going to be defined for a particular container type. And therefore, the definition of what this operation means is going to be dependent on the type of iterator that this is invoked for. It's not as simple as applying this to a pointer where you simply go out to the address, interpret it according to the base type, and get back the element residing there. No, because if we have an iterator for, say, a linked list, the dereferencing of that iterator is going to go ahead and provide us back the data stored within the node and not the node itself. So what we're going to see here is the focus is actually shifted from, as we iterated through kind of a linked list, to this capability that we're focused on the data. So dereferencing the data is going to go ahead and give us, dereferencing the iterator is going to give us the data to which that iterator points, you can think. Likewise, we're going to have an ability to move from one data within our sequence to the next. And we're going to use the increment operator to go ahead and move us from the current data being pointed to the next within the sequence. The cool thing about this operator is, again, it's going to be defined for a particular iterator type. So if we were dealing with an iterator for a linked list, this would essentially do the cur is equal to cur next operation. If we were defining this for a vector, I mean, it would be very similar to what you would expect this operation to be defined when invoked on a pointer. So there's two of them. There will be kind of another one that we're interested in here too, and that's going to be a test of equality to see whether two iterators are pointing to the same data. So the key operations of an iterator are going to be to access the element that we're currently visiting, so dereferencing with the dereference operator, an ability to move to the next element in the sequence, so increment operator plus plus, and then also this idea of to check to see whether two iterators are visiting the same element. And we'll see why this is super important when it comes to traversal, because if we have an iterator to the first element in a sequence and we move it as we're traversing the sequence, we'll also have an iterator at the end. And when that iterator that we're using in the traversal meets that at the end, and we'll do this by a comparison, we will know that we have visited every node within our sequence. And the other thing I'm going to go ahead and point out here is there are different types of iterators, and some are going to support additional operations than those listed here. There's random access to iterators, which essentially allow you to jump to a specific element within a container. There's also bidirectional iterators that not only implement increment, but also implement decrement. And we'll kind of, it kind of makes sense. I mean, you can think about maybe a singly linked list iterator would only allow you to move forward. However, a doubly linked list iterator could take advantage of the previous pointers and allow you to move forward and backwards. Likewise, an iterator for something like a vector who's storing its data in an array, you could go ahead and have some sort of random direct access to a specific element within that collection. So this is kind of the bare bones operators that we can expect more or less all of our iterator types to implement. However, do understand that there are more extravagant iterators that can do even more than just this. So here's a pair of iterators. Go ahead and understand that they define a sequence because we have a beginning point and end to that sequence. And they'll go ahead and allow us to iterate through different types of containers in the same way. Because again, remember, if moving this iterator, and this is an iterator, so it supports the dereference operator. So begin dereferenced would give us 7. Plus begin would move begin to the next element. And then equal would allow us to do something like if begin is not equal to end, or while, let me erase that, maybe while begin is not equal to end, go ahead and increment begin so that we continually move from one element in the sequence to the next. But notice here how this is taking away the need to do something like we had with pointers, where we had to physically move, where the pointer was physically pointing at a particular node within this sequence or within our linked list. And to move it kind of forward, we had to do something like cur is equal to curs next. If we wanted to jump to the next node within our sequence, if we wanted the data, we had to dereference cur and then access the data member, which we said was equivalently written as curs data. And then if we wanted to compare two pointers, I mean, we're aware of how to do that. We could do things like curs not equal to null pointer. So what's the utility of these iterators? Well, let's revisit that in a second. Let's just walk through this. So again, let's assume that as opposed to calling it begin, we call it iter. We use the increment operator to move from one element within our sequence to the next, to the next, to the next. And if we're writing a while statement governing this traversal, it would essentially be the conditional would be while iter is not equal to end, which is also an iterator. So continuing, okay. So here's a key takeaway, and we'll see the implications of this for the standard template library. So algorithms manipulate data, but don't know about containers, right? If we want to have a generic algorithm, it cannot be focused on, say, a particular container if we want that algorithm to be general and be allowed to, or able for us to apply it to multiple container types. So if we want a generic algorithm, we can't have that algorithm depending on the underlying structure of the container. Likewise, we're going to want to have containers that store data, but don't have to know anything about algorithms in order for us to use them within an algorithm. And what we're going to see, especially when we get into the standard template library, is algorithms in containers can interact through iterators. So remember when I wrote out that while statement for you? For our linked list iterator, didn't that look kind of like that? Notice how I said through a linked list iterator, we could get the data by just dereferencing and maybe checking it against a value in a find algorithm implementation. If we return first, well, that's an iterator. We could go ahead and return it. If we want to move to the next data within our sequence, we can increment that iterator. And then if we don't find anything, well, we could simply return last. So again, that's all going back to what I kind of drew out here. And I said, look, iterators are different than pointers. An iterator for a linked list, if you were to dereference it, you're not getting the node back as you would with a node pointer. Instead, you're getting the data residing in kind of the node and where you are on the traversal. And we'll see how these are defined to implement this sort of behavior that we're observing. And again, plus begin moving us to the next. And again, we need to have some sort of equality operators defined so that we can tell or compare two iterators and know when we're at the end of a sequence. So we'll get into how you can get an iterator for an STL container here momentarily. Let me go ahead and jump over this because we are going to pick up right here in the next video, and I'll go through the actual implementation in a forthcoming lesson. It's just I don't think we're going to have time to do that today.